Thank you. So yeah, hi everyone. I'm Matt. I work at an insurtech here in the UK, actually Stockport, called CDL. This is basically a story of our data migration to AWS. So I joined CDL in 2014 as an Oracle DBA. At that time, we operated out of 2 data centers in Stockport, and they cost about £4 million each to build. As you all know, customers demand high availability from software solutions. So in addition to the 2 data centers, we built out what we thought was a really robust database architecture running on Oracle. So we had Oracle Real Application Clusters. So within a single data center, if the database failed, it would move over onto one of 2 additional nodes. If all the nodes in the data center failed, that was okay because we were running Oracle Data Guard. So we could fail over to the second data center down the road, which had the exact same 3-node cluster setup. Database software ran on Oracle Enterprise Linux, and we used K-Splice at the time to allow us to patch the operating system with minimal downtime. We ran Oracle VM on top of Oracle hardware with all the CPU pinning in place to meet all the very complex license requirements. For storage, we had NetApp that gave us mirroring of backups across dedicated links between the 2 data centers. And all our monitoring was done by Oracle Enterprise Manager. And we had an open source piece of software called Rundeck, which we used to help us schedule and manage all of our database jobs like backups. As you can tell, we were all in on Oracle. We had a team of Oracle DBAs. We also ran for our one of our main applications, which is the migration story of. We ran the middleware for that application on Oracle WebLogic. There was a lot. Oh dear. It gets better, honest. There was a lot to look after, but it all worked, and we were actually really proud of the high availability we actually delivered to customers. And then, as you might expect, when our licensing deal came up for renewal, the price changed. And it quickly became apparent that we needed to move to a different database to have a cost-optimized solution. At this point, it was kind of like late 2015. We'd recently started developing a brand new product, and we were doing that in the cloud with AWS specifically. So we already had some experience on AWS. But at that time, for various reasons, we still saw a need for on-premise deployments for this particular application I'm talking about. So some of our DBAs started to look out at building a new Postgres-based architecture that would work both in the cloud and on-premise. We spent around 6 months trying to get this architecture that you see on the screen here. So it's Postgres running on VMware, NetApp for storage again, Patroni we had in place for failover, and that also required to have a distributed configuration store, so we deployed and managed etcd. NetApp at the time didn't have a driver for Postgres, so for doing database snapshots, so we had to write scripts. We actually got all of this built, and we were running it in development environment. And then one day we did an upgrade on Patroni, and it failed, and we got really stuck. And it took us a while to bring it back. At this point, CDL had announced that we were cloud first, but not yet cloud only. However, we took the decision not to build out a database service on premise. It was going to be too much work. And what we realized is we hadn't actually got to work on the business problem yet, which was migrate an application from Oracle to Postgres database. What we were actually working on is a load of plumbing that we thought was needed to work on the business problem. So it'd be kind of easy to write off all that kind of on-premise work on Postgres as a total failure, but it wasn't really. The team at the time still all had Oracle DBA job titles, so learning Postgres from the ground up taught us a lot and helped us later on. Moving to RDS removed a lot of the fear of all that plumbing work and the potential failures that we might need to deal with as a team. We're still learning, but that kind of learning shifted away from infrastructure, and we started to look at PG stat statements, CloudWatch, PG Badger, and learning the differences in dialects in SQL between Postgres and Oracle. So I'll take you through the steps that you would want to take when doing a typical Oracle to Postgres database migration. So first of all, you mentioned it earlier. So schema conversion tool, SCT, that's going to give you a report on what you're going to need to change. You're going to get some scripts out the back of that. It's kind of like a one-time thing. And that allows you to create your RDS database and in Postgres and create your schema. Second, you need to get your data over there. So we've already had an introduction to this. You're going to want to use change data capture, CDC. And this will transfer all of your tables, your primary keys, and your data from one source database to your target database. Then you can migrate over your views, functions, indexes. In Oracle, there's database code, so PLSQL. If that will need to be converted, if you're still going to have it in there, to PG PLSQL. You probably find that your application over time has got some Oracle-specific functions in there. Be warned, some of this will be in the database code, but some of it can creep into the application code as well. We also found Oracle features in the business intelligence solution that supported the product that we've migrated that had no equivalent in Postgres whatsoever. A bit more on that later. So, change data capture. Transactions are read from the source online transaction processing database and then are sent. In our case, we used a piece of software called Click Replicate, so it's similar to Debezium and DMS that have been mentioned before. And transactions are applied to the Amazon RDS instance. We use Click over the others kind of out there because we already had experience with it. So for us, it made sense for us not to have to learn another thing. So if you were a Click-based solution, this is the type of architecture you need. You need a source database, you need Click Replicate software, Click Enterprise Manager, which helps with some of the automation, and a target database. And these components all need to communicate with each other, so you need things like security groups in place. You also need to define replication tasks. So this is the process that defines the data between the source and the target and any mappings that happen. And what we did was we used APIs available in Click Enterprise Manager to be able to automate all that and the automation of the various replication servers and the creation of the task definitions. I guess this is kind of treading on the toes of the previous talk a little bit, but application modernization, another great use case, I think anyway, for CDC is to help you move towards an event-driven architecture. This certainly isn't the end state, so this is while you're doing the rest of your modernization. But change data capture tools like Click can support multiple targets, so even when you're using like a large relational database as a source. So with this, you can point CDC at your existing kind of legacy app and have the CDC software put that onto a more modern event-driven data store. So it could go to S3, for example, and then from that, you could have new functionality for your product or application read based on events from the data landing in S3, those trigger Lambda functions. So you can write new application in a really modern event-driven way. And then whilst you're kind of strangling the rest of your app, and the only thing you need to worry about is once you've removed your legacy, that the message that goes into essentially S3 in this case is the same, and then the new functionality will continue. So that's a bit of a tip there, how you can move to the new world whilst still supporting legacy. So in addition to kind of using the Enterprise Manager stuff for the deployments and registering all the task definitions, we actually used it to track our database migrations as well. So the REST API has been expanded over time. We've been using it to gather all the metrics and basically pump that into, well, this is Elasticstack, but we moved to OpenSearch since then. And this is one of the Kibana dashboards. So we're able to visualize kind of key replicate metrics. So things like the maximum latency, both current and over a period of time. You can also kind of see in the gauge, we were doing multiple database migrations. So the gauge is kind of like the average latency over the kind of estate that we were managing. Things like CPU and memory utilization, and also kind of at the bottom, the replication tasks, whether they're kind of in a good state or a bad state. So with kind of those steps for migration defined and tested, you're going to have to repeat them a lot. So we had about 600 databases to migrate. So we needed to automate. So we created our change data capture tasks in the click replicate console, then we exported the definitions as JSON, and we used the JSON as a template for each migration to make it config driven. So just kind of finding and replacing kind of key variables like client name, schema name, host name, things like that. The automated migration process then can have an input file of variables, and when we started the migration, we locked all of the Oracle database accounts, then rolled back if we needed to. It was just a case of unlocking those Oracle accounts again and pointing the application back. And we deployed all this as infrastructure as code. So some benefits of that, reducing the risk. I'm not my best doing a deployment, a manual deployment late at night, for example. I'm probably going to make some mistakes. With the infrastructure as code, you get the same thing every time. And also you get speed of deployment. So for us, ability to roll out changes quickly through multiple environments and for multiple customers at the same time without having to scale up our team to do it is really important. Okay, so after the initial migration of the database in the development environment, we started up our application. This is what happened to us. Well, for a start, it failed. There was lots of connection, kind of initiation SQL statements being run, all trying to select from the dual table. This is an Oracle only thing. So what we did is create like a fake dual table in Postgres to get us up and running, whilst we kind of refactored the code in the application later on. On the second attempt, the application started, but it was way too slow. So we had developers saying this screen kind of used to take 3 seconds, now it's taking 2 minutes, or it's even timing out. And what we saw was a horrendous number of joins in the SQL, and it was also bringing back a lot of unnecessary columns. So at this point, we kind of changed about 10 different database views to make the application usable, and then we carried on with the tuning and we looked at specific things in Postgres. So join collapse limit. So this influences the query planner in Progress to rewrite explicit join constructs. So if you've got a smaller value for this, it reduces the planning time, the execution time for the planning, but it might yield inferior query results. So there's a trade-off there. Very similar is the from collapse limit. So this is about the number of effectively tables that you reference. So it will kind of try and merge subqueries together. So again, smaller values for this parameter will reduce the planning time, but it for us anyway, it had a big impact on the query plans that were being produced. Work mem, so this sets a kind of baseline minimum amount of memory to be used for each query operation. So for example, like a sort or a hash join. The default's 4 megabytes. For us, we found this to be too low. PG stat statements. So this is a module in Postgres used for tracking query kind of execution statistics for all the SQL statements executed by a server. So we actually loaded this at database startup using PG pre-warm, and this allows you also to cache data essentially. So we took use of that. Next thing is we turned on logging for any statement that was taking over, say, 1 second to execute, and we sent all those logs to OpenSearch. And this identified like poor performing SQL that we could then go and repeat these kind of tuning steps for, and to kind of rinse and repeat, sticking the changed SQL into a dev environment before we moved it formally into the code base in the application. We still have all of that logging turned on and going to a database dashboard, in OpenSearch. Basically, this really helps us, so we see poor performing SQL in a non-production environment before it starts to affect a customer. We also tried out lots of tools too. Postgres logs being shipped to AWS CloudWatch logs, Amazon RDS Performance Insights, which is a database performance tuning and monitoring feature. We use something called PG Badger, which is a Postgres log analysis report tool. The most interesting thing, I think anyway, is what happened organizationally. So the DBAs had moved from kind of managing the whole kind of database stack to move it to using RDS. So as they were not installing database software, they had more time to work directly with the development teams making the software better. We kind of found by accident that we ended up doing DevOps. So DBAs sat next to the developers working together and not having to kind of raise tickets to talk to each other. And this just sort of happened. So kind of touched there on DBAs not installing database software, and RDS is also handling the patching and the backups. So often what I get asked is, well, what do the DBAs do now? For yours, the answer was automation on top of the automation. So they build and maintain Terraform for infrastructure as code. They build and maintain pipelines. They use a Terraform kind of tool called Atlantis, so they can roll out new environments through config. They're also able to move the database technology on much faster than they ever did. Historically, on premise, our Oracle 11G to 12c upgrade took us a year to complete. Now we have RDS and automation. We can move between major versions of Postgres in 4 weeks. We're actually throttling this ourselves. We could do all of them in one night if we wanted to. So we can roll out new clients faster. We can roll out kind of critical bug fixes faster. We can really now go as fast as the business wants. The tech, in this case, is no longer our bottleneck. It's actually risk appetite from CDL or our customers on how fast they want to go. And also the DBAs think about CDL growing. What happens when they have 1,000 databases or 2,000 databases? Well, with all of the kind of automation that they've built, we're not too worried about having that scale to deliver the kind of company strategy. So automation, it's also improved the developer experience at CDL. The DBAs basically come up with a self-service functionality that they've built on top of Rundeck. So things like developers often require clones of production databases to work through potential bugs or test at production volumes. And through this self-service portal, developers can basically create their own database clones. So we have an automated process that does a point in time of recovery on a production database to a new database instance. They downsize the instance class and make it single AZ to save costs. And then there's an automated kind of masking process that runs to protect sensitive data. And finally, the process issues a temporary set of database credentials to the developer. We used to have something similar on premise. So for large clients, this process could take around 18 hours, but the DBAs have optimized this in RDS by doing basically production clones every weekend and taking an RDS snapshot that we then make available to their non-production accounts. So now a self-service in AWS, the 18-hour process now takes 18 minutes, and an 8 terabyte database is ready within 30 minutes for a developer to use. Other thing is developers often want to check like config data in production environments. So we've made kind of pre-approved queries to be executed. They can just execute them against the production databases via self-service. And also in the event of a customer-facing incident, DBAs used to be tied up a lot with getting asked to run like health checks on the databases to help triage where the incident should go. So they've basically scripted all of that up now and made it directly available to kind of the service center, the ops center, to run without having to wait for a DBA to do it. Customer testing, that's also been improved because cloning from production to training in UAT environments, that's all automated and can be requested through the self-service portal. And you don't have to wait for a DBA to do an export and an import. Basically, the database at CDL has become a product in itself. It's built on top of RDS, of course, but we're adding value that's specific to the needs of our business. Also, the DBAs have actually changed job titles. They've actually changed to be data engineers now. And through that kind of process, they kind of write code, they create automated processes. They really are building a product. They're also got more time to learn new skills. So a lot of the DBAs have moved on to different types of projects using technologies like EMR, Spark, Athena, QuickSight, to name a few. Couple of points on AWS programs to help you. So Amazon have a thing called Amazon RDS Ready. So this is where your product uses Amazon RDS as your database. Basically, if you've ever done like a well-architected review, it's very, very similar process to that, but the questions are obviously focused on RDS. And there's a set of criteria that you can go through to help you make best use of RDS. So I'm rapidly running out of time, but the criteria kind of covers things like connection pooling, application logging, encryption, and database failure and performance. So for us, we had we spun up a replica of the database, and we ran a Gatling performance test on a private car insurance quote, because that's our kind of highest volume throughput through the application. So we ran this for 30 minutes. At the 10-minute point, we did an RDS failover from primary to standby instance, and we watched what happened. Did the application recover or not? So it did, and that's one of the criteria you have to meet to be RDS ready. I mentioned before that we found something in the business intelligence solution that had no equivalent features in Postgres. So this is fast refresh materialized views. Basically what we ended up doing that was work with the AWS Database Freedom team to basically create that functionality in Postgres. So AWS found us somebody who was familiar with kind of materialized views, and helped us write that code. We've open sourced it, so it is freely available, so you can scan that QR code. We continue to maintain it. There's a couple of people out in the world that are using it as well as us, but it's in our GitHub repo, so feel free to take it, use it, enjoy. The principal engineer on that project is a guy called Tony Mullen. And the QR code will take you to Tony's blog post as well. I think he must have done a good job, because he now works for AWS as a senior SA specializing in RDS. Check out Tony's blog and the code. I'm going to skip to the end because I'm running out of time. This is just a walkthrough of setting up that GitHub project, but there's a full README in the repo anyway. And I'll give you a final tip to close. So obviously AWS give you some really awesome building blocks to build out your applications with, but for our migration to succeed at scale, we needed the help of all of our teams. So engineers, of course, to do all the interesting things that I've talked to this technical group about today, but we also required like legal, compliance, project management, service management, and customer teams to make the migration of our flagship product cloud only. So we recognized every migration as it happened by hanging a cloud at our campus in Stockport. And after the last migration completed, we had a cloud celebration day. So it was about 200 CDL people came to our campus alongside our AWS account team for food, drinks, and fun. We recognized key individuals, but one of the things we did was give everybody an extra day holiday for the mammoth effort that they put in to make this a success. Recognize the people, because it's them that make it happen. Thanks very much for listening.